Hi, my name is Varat Pangprasert. My student ID is 6301002630084.
Hi, my name is Sujiporn Manpan. My student ID is 6301002630114.
Hello, my name is Suvatalachai Kawi. Student ID 63 10 26 30 131.
Hello, my name is Miss Kana Thongkes. My student ID is 6301002630122.
Today we are going to talk about aircraft fuel tank construction. The Federal Aviation Administration, or we call FAA, is the agency of the United States Department of the Transportation responsible for the regulation and oversight of civil aviation within the U.S., as well as operation and development of the national airspace system. Its primary mission to ensure safety of civil aviation. Limitation to design aircraft fuel system of normal, utility, acrobatic, and commuter category airplanes. First, design and arrange to provide independence between multiple fuel storage and supply systems so that the failure of any one component in one system will not result in loss of fuel storage or supply of another system. Second, design and arrange to prevent ignition of the fuel within the system by direct lightning strike or sweep lightning stroke to areas where such occurrences are highly probable, or by corona or steamering at fuel vent outlet. Third, provide the fuel necessary to ensure its power plant and auxiliary power unit function properly in all likely operation conditions. Fourth, provide the flight crew with the means to determine the total usable fuel available and provide uninterrupted supply of that fuel when the system is correctly operated, accounting for likely fuel fluctuation. Fifth, provide a means to safely remove or isolate the fuel stored in the system from the airplane. 6. Design to retain fuel under all likely operating conditions and minimize hazard to the occupant during any survivable emergency landing. 7. Prevent hazardous contaminations of the fuel supply to its power plant and auxiliary power unit.
Okay, next. This is the part 1. Limitation to design aircraft fuel storage system of normal, utility, acrobatic, and commuter category airplane. First, withstand the load underlying operating conditions without failure. Second, be isolated from personal compartment and protected from hazard due to unintended temperature influences. Third, be decided to prevent significant loss of fuel storage from any vent system due to fuel transfer between fuel storage or supply system or underlying operating condition. Fourth, prevent fuel for at least 1/2 hour of operation at maximum condition power or TAT. Fifth, be capable of jettisoning fuel safely if required for landing. Okay, this is the part 2. Limitation to design aircraft fuel storage. Refueling system of normal, utility, acrobatic, and commuter category airplanes. The first, prevent the occurrence of any hazard to the airplane or to person during refuel or recharging. Second, prevent contamination of the fuel storage during lightly operating conditions. Third, prevent improper refilling or recharging.
Types of aircraft fuel tanks. Rigid removable fuel tanks. Many aircraft, especially older ones, utilize an obvious choice of fuel tank construction. A rigid tank is made from various materials, and it is strapped into the airframe structure. The tanks are often riveted or welded together and can include baffles, as well as other fuel tank features. They're typically made from 3003 or 5052 aluminum alloy or stainless steel and are riveted and seam welded to prevent leaks. Many early tanks are made from a thin sheet steel and coated with lead or thin alloy called turnplate. The turnplate tanks have folded and soldered seams. Figure 1 show parts of typical removable fuel tanks. Regardless of the actual construction of removable metal tanks, they must be supported by airframe and held in place by sort of padded strap arrangement to resist shifting in flight. The wings are most popular location for fuel tanks. Figure 2 show fuel tanks bay in a wing roof with a tank straps. Some tanks are formed to be part of the leading edge of the wing. These are assembled using electric-resistant welding and are sealed with a compound as it pour into the tanks and allow it to kill. Many fuselage tanks also exist. Figure 3 in all cases, structural integrity of the airframes does not rely on tanks being installed, so the tanks are not considered integral. Being able to remove and repair or replace a fuel tank can be a great convenience if a leak or malfunction with the tank exists. Repairs to the fuel tanks must be done accordance with manufacturer specifications. It is especially critical to follow all safety procedures when welding repairs are performed. Fuel vapors must be removed from the tanks to prevent explosion. This typically involves washing out the tank with water and detergents, as well as some number of minutes that steam or water should be run through the tanks. Time varies by manufacturers. Once repaired, fuel tanks need to be pressure checked, usually while installed in the airframe to prevent distortion while under pressure. Bladder fuel tanks. A fuel tank made out of reinforced flexible material called a bladder tank can be used instead of a rigid tank. A bladder tank contains most of the features and components of a rigid tank, but does not require as large an opening in the aircraft skin to install. The tank, or fuel cell as it is sometimes called, can be rolled up and put into a specially prepared structure bay or cavity through a small opening, such as inspection opening. Once in size, it can be unfolded into the full size. Bladder tanks must be attached to the structure with clips or other fastening devices. They should lie smooth and unwrinkled in the bay. It is especially important that no wrinkle exists on the bottom surface, so that fuel contaminants are not blocked from settling into the tank sump. Bladder fuel tanks are used on aircraft of all sizes. They are strong and have long life with seams only allowed installed features, such as the tank vents, sump frame, fuel spout, etc. When a bladder tank develops leak, technician can patch it following manufacturer's instructions. The cell can also be removed and sent to a fuel tank repair station familiar and equipped to perform such repairs. The soft, flexible nature of bladed fuel tanks require that they remain wet. Should it become necessary to store a bladder tank without fuel in it for extended period of time, it is common to white the inside of the tank with a coating of clean engine oil. Follow the manufacturer's instruction for the dry storage procedure for fuel cells.
Integral food tank. On many aircraft, especially transport category and high-performance aircraft, part of the structure of the wings or fuselage is stainless, which are full resistant to pass fuselage to form a fuel tank. The fuselage skin and structural member provides the high volume of space available with the lowest weight. This type of tank is called an integral fuel tank. Size: it forms a tank as a unit within the airframe structure. Integral fuel tanks is the otherwise usage space inside the wing are most common. Aircraft with integral fuel tanks in the wings are said to have wet wings for full-minimum purpose. Sometimes a wing is split into separate tanks and may include a shaft tank or the overflow tanks, which is normally empty but useless to hold fuel when needed. When an aircraft maneuvers, the low horizontal nature of an integral wing tank requires buffing to keep the fuel from sloshing. The wing ribs and box beam structural member, survey and buffers and others may be as specially for that purpose. Buffer shades reversed are commonly used. Thereover, allow fuel to move to the lower inboard section of the tank, but prevent it from moving outboard. They ensure that the fuel boost pumps located in the bottom of the tank at the lowest point above the sum already have full. Two pumps, regardless of aircraft altitude. Picture 6. Integral fuel tanks must have extensive process of inspection and repair of the tanks and other fuel system components. All large aircraft that necessarily enter the tank of maintenance transport category of aircraft often have more than a dozen outer exit panels or tank panels on the bottom surface of the wing for the purpose. Picture 7a. These aluminum panels are seated into parts with an O-ring and aluminum gasket for electrical supporting. An outer covering is tightened to the inner partner with screw, as shown in Picture 7b. When entering and performing maintenance on an integral fuel tank, all fuel must be emptied from the tank, and strict safety procedures must be followed. Fuel bottles must be packed from the tank, and repository equipment must be used by the technician. A fuel transporter must be positioned just outside of the tank to assist if needed. Aircraft using integral fuel tanks normally have sophisticated fuel systems. This includes in-tank boost pumps, There are usually at least 2 pumps in a tank that deliver fuel to the engines under positive pressure. On various aircraft, the in-tank boost pumps are also used to transport food to the other tank, injection fuel, and therefore the aircraft. Thank you.